Test, test. Hello? Hello? Slow there. All right. Hello, everyone. Welcome. Good afternoon. I hope you're all doing well. A couple of announcements before we take a look at some code today. I'm sure you're probably wondering about the exam that you took last week. Those scores should be posted by tomorrow. So we are not quite done with grading yet, but we're very close. So I think definitely should expect those scores to be posted tomorrow. And it'll be the same process as last time where you'll have a week or so to submit any regrade requests and such like that. I also wanted to point out that we're getting kind of close to the end here. Counting this week, we have 5 weeks of class left, and then finals after that. So we actually have 4 studios left, but we have 3 assignments and 3 quizzes. And 2 more exams, exam 3 and the final exam. Although, of course, as you're probably aware, you get to drop an exam, so you may only need to take one of those exams, depending on how well you're doing. But just want to make you aware that we are getting kind of close to the end here. There are fewer opportunities to affect your grade in this class than there were at the beginning of the semester. So if you're concerned about where you currently stand, I would encourage you to make an appointment with me or with Professor Nuri and come in and talk about it so that we can come up with a plan and do what we can to get you up to speed and finish the semester strong. So I think that's all I had in terms of announcements. Did anybody have any questions about logistical stuff, calendar stuff before we hop in and take a look at some code today? Not seeing any questions, which is great. So yeah, let's chat about today's topic. Actually, today is kind of a big day. I would say that basically everything that we've been working towards, everything that we've taught you this semester has basically been building up to today, building up to this moment. Today is hopefully not the end of your, programming journey, and you'll still be learning lots of stuff even after this class is over. But in terms of this class, it's definitely a milestone. It's definitely a very important point. The idea of objects is one that persists across many different parts of computer science, many different parts of programming. Understanding what we mean by objects in the computer science world is pretty essential to be a programmer in today's world. So that's what we're going to be talking about today. And to kind of explain a little bit what we mean by objects, let's think back to the very first class where we introduced types of things to you, such as ints and strings and doubles, right? Booleans. We've introduced several types to you, but consider that there are some things that are too complex in the world to be represented as a single number or a single piece of text. It would require perhaps many values, multiple values, to represent some of these complex kinds of objects. Some of the ones that we're going to be taking a look at today are person and student and car. So, these are things that are more complex than can be represented by a single value. So what objects do, one of the big things that they do is they take multiple variables, multiple values, and they package them up into one unit. We call this encapsulation. That's really one of the big vocab words for today, one that you might see coming up on exam 3, for example. Objects are used to encapsulate multiple values so that we can discuss them together as one more complex value. And so we see here, actually, in the person class, the very first example from the unit, that we have 3 what we call instance variables. So this is different than how we're used to declaring variables, right? They're declared not within a method, but within the class. And the reason for doing so is that these variables can now be accessed by any of the methods in the class. We say they have class level scope, as opposed to the variables that we've been talking about before today. When we talked about methods a few weeks ago, we talked about method level scope, and that's kind of something that you all have gotten used to as you've been getting more and more practice writing methods. But for an object, it makes sense that they can share these variables across all of their methods, and so instance variables have that. I also think it's important to point out what the relationship is between the object and the instance variables that it contains. I would describe this as a has a relationship. And I will even say this out loud. I mean, or maybe just in my head, right? To make sure that the instance variables make sense for the given object that I'm working with. So a person has a name, a person has an email, a person has a phone number. That makes sense, right? If I said, a person has a tail, uh, maybe not so much. A person has flippers. Okay, that's not something that people have. That belongs in a different object. So that has a relationship, I think, is a good one to keep in mind as you're working with objects, as you're creating objects. That's something we're going to take a look at the end of class today. How do we actually design and create these objects ourselves? Keep in mind that they're all going to have this has a relationship. The other new thing that we're seeing with these instance variables is out in front here, this word private. That's an example of an access modifier. I'm actually going to work through an example a little later on in class today where I show you exactly what private does and why we use it. But for now, one of the big takeaways and something else that will almost certainly be on exam 3 is to know that we mark all of our instance variables private, every single one. So anytime you're using instance variables, anytime you're declaring these class level variables, we want to mark them as private. Notice though, what we're not doing is setting them equal to anything. So I'm not actually saying name is equal to anything. That kind of defeats the purpose of having these instance variables, because what these instance variables represent is the attributes of the objects. And so what we're actually creating here when we write a class is a sort of like a template or a blank form that has, in this case, 3 blanks, one for the name and one for the email and one for the phone number. So, if we wanted to create a person object that represents me, for example, the name would be my name, Doug Shook. The email address would be my email address, dshook@worcester.edu. And the phone number would be my phone number, which I'm not going to say out loud and post on YouTube. So, um, but that's how the objects work. They have those values. They they are filled in when we create the object, or the more computer sciencey way of saying that is that we construct the object. And that's the next destination for us when talking about classes, is to look at this guy, which is called a constructor. Constructor has one role. The constructor's job is to make sure that all of the instance variables are set to an appropriate value. That's how we create an object. That's how we create what's called an instance of an object. So once we have all 3 of these instance variables, or however many instance variables there are, right? There could be more or less. But once all of these instance variables have been set to a proper value, they're not just empty, but they actually have valid information in them. We have successfully created an instance of an object. And the instance will represent, the object that has those properties. If we wanted to create another person that represents my daughter, for example, we would call the constructor method again, create another instance of person. But this time, of course, it would have her name and her email address. And, well, she's only 7, so she doesn't really have a phone number yet, but she'll have one day, I'm sure. But anyway, we can call this method as many times as we need to and create as many person instances as we may desire, right? So the constructor's job is to make sure that all those instance variables get set. And you can see that the way that it does that is by taking those values in as parameters. That's not the only way it happens, although it is a very common way. We'll see another way that constructors set instance variables in some other examples. But the other thing I want to point out is, okay, when we look at the constructor, it says public person. It kind of looks like we forgot some things there. Notice the word static doesn't show up. Actually, we're going to start seeing the word static a whole lot less after today. I'll talk about that a little bit later on as well. We also don't see, what other piece is missing here? Public, static, what comes after static usually? The return type, yeah. And it doesn't look like there's a return type here either, which there isn't. This is actually just the name of the method, which you may have noticed is exactly the same as the name of the class. That is not an accident. That is how constructors are always written. So whenever you see what looks to be a method that has the same name as the name of the class, that means that what you are looking at is a constructor. And to be clear, constructors are methods. They're just methods with a very specific purpose, which is to create instances of the class. And the way that they create instances of the class is to ensure that all of these instance variables are set to proper values. So I know that's kind of a lot, but that is like object-oriented programming essentials right there, right? Understanding the idea that we have different instances of objects that we get by calling the constructor, and those instances are going to have the same variables, but those variables will have different values depending on the instance that we are trying to represent, the person or the car or the student or whatever it is that we're trying to represent. Any questions about that before we move on to the next topic? Because that's pretty heavy stuff right there. I'd be happy to re-explain, clear up any confusion. Okay. So then the other thing that classes and objects provide for us is methods. So the constructor actually is a method, but it's a very special method. It's used to create instances, as I talked about. But classes can also contain other methods. So this is an example of a print method, and the methods describe the behavior of that object. So these instance variables would be the attributes, right? But the methods describe what the object can do. So methods are usually verbs, they're usually actions, behaviors, and you can, we've written methods, we've been writing methods for the last couple of weeks. And so the same rules that have apply to most methods apply here, but you'll notice that the methods are accessing the instance variables. That's a big change, right? Before we would only really use the variables that we get from the method itself, or maybe if there's input parameters. But now we're actually accessing these instance variables, and that actually changes the way that we use the method, that we actually call the method as well. If we scroll down here to our main method, which is the one remaining method that is going to continue to use the word static, by the way. Here is an example where we actually call the constructor and create an instance of the class. And I actually want to draw a little diagram, try and, illustrate what happens on your computer when you execute a line of code like this. Because, we're looking at the main method, the entry point of our program. When we first start the program, we have nothing, right? There's no objects, there's no variables, there's no nothing until we do something. So what is this actually doing? When we call the constructor, when I create an instance of an object, what does that actually look like on the computer? Let me quite literally paint a picture for you using my admittedly mediocre drawing skills here. When I create an object, that's like picking out a location on your computer. Imagine this is the memory of your computer and saying, hey, I'm going to put the object there. How that happens, way outside the scope of this class. There's a lot of stuff that I'm kind of glossing over, but it has to live somewhere, right? The object has to be somewhere. So we're just saying, all right, it's going to go there. And then once we've determined that, we're basically going to fill in those instance variables with the constructor. So if I look at the very first person that gets created, you can see the name is Sana and the email address is sana@gmail. And so inside of that circle, we're essentially saying what these are. We're remembering them. Email is sana@gmail. And what was the last one? Phone number. Thank you. Yeah. So the actual phone number doesn't matter. It's a phone number, right? And just need to make sure we can see all these. There we go. Perfect. So all of those values are stored within the object. But that's not quite all that's happening here, because as you will notice, we're creating a variable over here. What's the type of the variable? Person, person, which might seem simple, right? It says it right there, but that's actually really big. That's huge because before today, the only variables that you were creating were ints or doubles, strings, right? Things like that. Whereas now we're actually creating a person type, which I want to remind you is a type that we create. Well, it was kind of given to you, but it was created, right? This is a type that does not exist by default. It was created. So when we create classes, what we're really doing is saying we want to create a new type. And anywhere that we have used types in the past, we can now use the class as a type. We are creating a brand new type that can be used within our code. And that's exactly what we're doing here. So returning to the diagram, when I see that I'm declaring a variable, it's called P1. And so that is like a big old sign or an arrow that is pointing at this object. So there's a big old sign pointing at this object that says P1. This is where P1 is, right? So whenever I want to access these instance variables inside of here, I actually have to go through this P1 variable first to do it. And the same goes for methods as well, which I'll get to in just a moment. Before I do, I want to actually sketch this one out because we're creating a second person object, right? So if I wanted to do the same kind of idea again, we would draw our circle, and then inside of that circle, we have to fill in all of the instance variables with the values. Okay. And just like before, there was a variable created, so that variable is going to be essentially pointing. These variables are actually called pointers in some contexts or references. Those are two words that basically mean the same thing in this context. And so we'll have another variable P2 that is pointing at the object that got created. So then we want to use methods. You'll recall from our conversation about methods, a few weeks back, we have to first define the method and then call the method. And the same thing is true uh, now, except the big difference is that we have to access that method through an object. So with our static methods, the methods that you were writing last week on the exam, there were no objects. You just write the name of the method, you plug in the values, and it does its thing. Uh, Now we have to add one more piece of information, which is which object do we wish to execute that method. So our methods are no longer just operating independently, but they are operating upon an object. When we call a method, we are telling it exactly which object we want it to operate on. So referring back at this main method again, we see that right here, we call the print method, but which object was it called on? Well, that's where we look at the left-hand side of the dot and see that, oh, that was called on the instance that is P1. And then down here, we see P2.print, meaning that it's going to run the exact same method, but this time it's going to run it on the instance called P2. In fact, I want to take a second to run this through the debugger and show you exactly what it'll look like, because I think that's important to understand from the perspective of the computer, what does it see as it does these things? So I'm going to put a breakpoint here on line 26, which is the very first line of the program where it calls the person constructor. And I will start it up in debug mode. So the first thing it's going to do is it's going to create the instance. It's essentially making, that circle that I drew on the diagram, but a bit more practical. It's actually on the computer. And if we look at our variables window, we can actually see here is P1. And if we expand it out, we can even see there are the three different instance variables and the values that are associated with them, which are the same ones that were passed in. Now pay attention when we go to the print method, right? If I say step into, the first thing that it says is to print out the name. Well, which name are we going to print out? if I look in my variables window now, I don't see P1, I see something called this. It's a very important keyword, one that we're going to be talking about a little bit later, but it represents the instance upon which this method was called, which in this case is P1. And if you expand it, you can verify that it is in fact P1, right? Because I see all the values for P1. And so as we proceed through the method, that's what gets printed out. I see all of the values from our P1 object getting printed out. Then we create our second person, P2, by calling the constructor, and then we call P2.print. So we're going to run the exact same method, right? The exact same code, but notice that instead of having P1's values, this time around, it's going to have the values from P2, because when we called the method, we put the P2 instance there. So the way that we write this line of code now becomes very, very important. The instance that we use on the left-hand side of the dot is going to determine how the method that is being called is actually going to operate based on the instance variables of that object. And so, as we step again, we'll see that, all right, the next time around, it prints out P2's information instead of P1. And this is object-oriented programming. This is the fundamentals, the nuts and bolts, creating instances, calling methods upon instances. This is how programmers talk about writing programs, creating big programs. This is professional grade stuff that is the bread and butter of any programming career. So that's one thing that I kind of want you to get used to, is talking about code in this way, creating instances, calling the constructor. I know it's a lot of new jargon, a lot of new terms coming at you, but it all has a purpose. And so, learning how to talk about it, think about these things in the way of a computer programmer is kind of the goal. Any questions about what I've covered so far before we move on to our next coding example? Yes.
So, constructor establish the do you always reference methods within the class using the variable name dot?
Yes. With object-oriented programming, if I am using constructors and instances, yes. In fact, I can go one step farther and show you that if I don't do that, if I try to do it kind of the old way, right? It'll tell me that I can't. It'll say, well, this looks kind of cryptic. Can't make a static reference to the non-static method, but it's basically saying, hey, you can't just call the method by itself. You have to have an instance of the object that this method is called upon. So it's telling us that we either need to create an object, or, if we have an object, we need to put it out front. The method cannot just run by itself. Yeah, good question. Any other questions? Yeah, in the back.
Both variables.
So the terminology does get a little bit confusing when we talk about what is an object versus like an instance, for example. I use the term object and instance interchangeably, but I think technically speaking, the circle is the object, and P1 and P2 are references to the object. They're pointers. They're pointing at the actual object, which might seem like I'm splitting hairs there, but I'm doing it for a reason, because it does matter. In a couple of weeks from now, if I'm not sure if I'm teaching that section or if Dr. Nuri is. We haven't talked about it yet, but we'll revisit this diagram and see that those references really matter a lot, and do a lot more gymnastics with these references than what we're going to do today. I'm trying to keep it simple today, but I'm glad you're thinking about that. Any other questions that I can address before we move on to the next example? I know this is new. I know that there's a lot coming at you today, so very happy to clear up any confusion. All right. So what I want to talk to you about next is actually writing some of this stuff. This was just kind of a tour through a class that already exists, just to kind of point out all the different parts and such. But if we actually want to write some of the stuff, how does that work? Let's talk about the decisions that we have to make, and how we can actually, connect everything up together. In particular, we're going to be writing our constructors. I think that's probably the most important thing when writing classes, Coming up with the instance variables, usually not too tricky. We're going to get some practice doing that a little bit later. Here they've been given to us, which is fine. But writing after you create your instance variables, I think the next thing on your to-do list should be writing the constructor. And actually, in this example, you'll notice that we have two constructors. So this first constructor that doesn't have any parameters, that's what's known as the default constructor. The second constructor is just, there's no special name for it. It's just another one, a second constructor. But the difference between the two has to do with me and or perhaps you, whoever the programmer is that's actually going to be creating the cars and using these constructors now has a choice. Do I want to create a very specific car that has a very specific model and year? Or do I not care and I just want a generic default regular car? That's what these two methods are presenting to us, right? So this is not unusual at all for there to be multiple constructors within a class. You'll probably see this. In fact, I know you'll see this on the homework assignment for this week as well. But within the one that is the default constructor, there's no parameters coming in. So we just have to say directly, what do we want the instance variables to be? We still have that role. We still have that purpose. We still have to make sure that all of the instance variables are set appropriately. But how do I set the model if there's no parameter coming in, right? For me to set to that instance variable. Well, I just have to say it directly. I would say this, you can see it's described as a default value. And actually, I have a little bit of an issue with the default value that they picked here from the textbook. They chose the empty string, which to me is borderline okay, I suppose. I would prefer for it to actually be something, not empty. So, the default model might be a DeLorean or something, I don't know. And for the year, we would then use the default value of 2019. But notice that if we call this constructor, we don't get to choose what these are. That's just what it is. Right? Whereas if I do care, let's say I want to make a specific car. If I don't care about the specifics of the car, I can use this default constructor and just get a generic car to play around with. But if I do care, if I need a specific car, for whatever the reason may be, maybe there's a particular model that I'm working on as part of my research, then I can use this constructor, which you can see has two parameters, one for the model and one for the year. And just like we saw on the previous class, we're just going to take those parameters and set them to their respective instance variables. So I would say model is equal to init model, and year is equal to init year. What this is doing is saying, hey, if you call this version of the constructor, then you have to tell me, you have to give me these two parameters, right? You have to tell me what the model and what the year are. But it's up to me, again, it's up to me to pick and choose which constructor I need for any given set of circumstances. So if we scroll down here and take a look at the main method for this example, it tells us to, call both of the constructors. For the first one, I'll call the default constructor, which will make I don't think they are making DeLoreans in 2019, but whatever, it's fine. We'll make a default car. Pay attention to this word right here. That's another important word. The new keyword. That is a big old flag saying, I'm about to call a constructor. That's what the new keyword means. The new keyword is saying, hey, I'm about to make a new object. We've actually seen that before. Does anybody remember an example where you've seen, I'm sorry? Arrays, yeah. So arrays are kind of interesting. They're sort of object-ish like, but also sort of not. Any other examples you can remember where we use the new keyword? I can think of another one. Scanner, good. Scanner. Scanner is an object. When you create scanner, you are creating an instance of the scanner class. And the new keyword is really your big red flag that is happening. Well, it's not a red flag. It's a good thing. It's green flag. Yes, we like creating objects. Objects are great. So the new keyword is a big old sign saying, "Hey, we're about to call a constructor here. We're about to create a new instance of an object." If I want to use the other constructor, it says it wants me to create a 2010 Honda Fit. It doesn't really matter. Uh, I used to drive a Honda Fit, but not anymore. Doesn't matter though. Make your car if you have one, or your neighbor's car, right? You have the flexibility. So here you get what you get. Here you get flexibility. You get to create the kind of car that you want to make. So providing multiple constructors gives us that flexibility, gives us that option. But regardless of how many constructors you have or what they are doing, the role remains the same, which is to make sure all instance variables are set to appropriate values before moving on. And I want to make it clear, one final note, maybe as we leave this example, move on to the next one. This one has 0 parameters. This one has 2 parameters. We could actually split the difference, and we could even make a constructor that just has 1. So think about what that would mean. That would mean that I'll use the existing parameter to set one of these 2 instance variables. But what do I do with the second one? Well, I just have to set it to some default value, right? So I could say the year is 2010 or whatever I think the default year should be. So we can mix and match. We can mix and match as well. Uh, Less common, perhaps, to do it this way, but not unheard of. And I think it's important to know that, you're not constrained here. You have the flexibility to mix and match and create as many constructors as you need to get that particular task done. That's ultimately what's important. Do you have the tools available to get whatever simulation, whatever model done that you're trying to do? That's the reasoning you should use to pick whatever constructors you need. All right. I want to move on to the student class next. And I actually want to focus on this private keyword for a minute. So I promised to show an example illustrating private. Private is an example of an access modifier. So it doesn't change the way that the variable works. It just changes when we can use it and where we can use it. So let's illustrate an example and then also kind of talk about why we like making things private, what the need is, what the necessity is. Actually, what I'm going to do for this example is this is a student class, right? And it has a few instance variables. But what I'm more interested in is, maybe creating another file um, called I don't know, database or something, right? Because as I'm sure you're all probably at least somewhat aware, as students at this university, you are in a database somewhere, right? Or probably even multiple WashU databases, right? They certainly keep information about all the students and me as well, too, as a faculty member. So the question is, how do we access that data and what kinds of things can we do with that data? For example, if I create a student, create an instance of the student to represent me, I actually am a WashU alum, so this was true at one point in time, even though I'm not currently a student. Fill in my values here. 7, sure. My ID number is 7. Great. So, okay, here is a student object that represents me, right? Uh, let's say, for example, I wanted to, uh, there's a bunch of other stuff here, so more stuff. But then later on in my code, later on in my program, let's say that I want to come here and say, hey, what is your ID number again? Can you just remind me? Can I go into this object and say, hey, tell me what that ID number was. Give me that ID number because I need it for a report or whatever the case is. So, How do we access that? How do we get to that information? One way you might consider, especially the way that we've been dealing with objects today, I could say myself.id. Maybe I just want to print that out. So go to this instance and tell me what the ID number is. And that seems like it might be a logical thing to say, but if you hover over this error, it tells me the field student.id is not visible. And the reason why it is telling me that is because that field, that instance variable, student.id is private. So this is a direct illustration of what the private keyword, what the private access modifier does. If something is marked private, I can use this variable inside of this class, inside of this file. As soon as I go to a different file, so as soon as I expand my program out and go to a different file, I can no longer access things that are declared private from outside of that class. They are not accessible to me. The private access modifier prevents me from accessing. So then you might say to yourself, okay, well, I really need that ID number. So how can I get it? I should be able to access my data somehow, right? And yeah, you definitely should. One of the immediate things you might think of is like, well, I know public is a thing that exists. You've seen it before. Why not just make this public instead? I've already kind of spoiled my own take on this, which is that I think this is the wrong thing to do. But why? Let's talk about why it's the wrong thing to do. If I switch this to public instead of private, and then I go back over to my database file, you'll notice that, oh, hey, that error just disappeared. That's great. I solved my problem. I made it public, and now I can even run this, if I want to, and see that it will happily print out my student ID number of 7. All right, everything's great now, right? Well, kind of, except by marking it as public, that also gives me the ability to do this. So, yes, marking it as public does let me see what that value is, but it also lets me change what that value is. Should I be able to change someone's student ID number? Probably not. I would imagine maybe it has happened rarely, very rarely, over the course of history here at the university, but it's certainly not intended. It's certainly not something that the WashU registrar is doing on a regular basis, right? Once you get a student ID number, that is your student ID number, and all of your records are going to be tied to that student ID number for the entire, the rest of eternity, basically. So it's good that public lets us do this, but it's bad that public lets us do this because I don't want people messing around with student ID numbers. That could be very dangerous. That could be a big problem. So what do we do? I want to allow this illustrates the two ways that we use our variables. The top is an example of reading the variable. The bottom is an example of modifying or writing to that variable. And so what I'm saying is I want to allow reading, but I don't want to allow writing. And you could imagine there might be some other situations in which, well, maybe I do want to allow writing, right, as well as reading. Or maybe I don't want you to see it, but I will let you write it. I'll let you change. So all of those potential combinations are possible, things that we might in fact care about. But how do we do it? Instead of marking things as public, so marking things as public is not it because that doesn't give us enough control. If we mark things as public, I can both read and write. So instead of doing that, we're going to use what are called accessor methods. Makes sense because I'm trying to provide access to these instance variables. There are two flavors of accessor methods, one for reading and one for writing. And we call them getters for reading and setters for modifying or for writing. And they both have a very kind of simple formula. So if I wanted to make a getter, for example, I would declare it as public. You can make methods private, by the way, and that has the same effect. That means that I cannot call this method outside of the class. You can only call the method from within the class, which does have its benefits. But we're talking about instance variables, so we'll keep using public methods for now. The return type is going to be this for a getter. It's going to be the same as the type of the instance variable that we care about. So public int get ID would then simply return ID. There we go. That's the getter. And if you wanted to make a getter for, a different instance variable, hopefully you can kind of see the formula there. If I wanted to do a getter for this, for example, getter, I would say get name, and it would return a string, right? So we can make a getter for any of our instance variables. We can make setters too. So if I wanted to make a setter, the return type would actually be void, and I would say set ID and take in a parameter. And then I would say ID is equal to new ID. So using the value of the parameter to change the value of the instance variable. But by doing it this way, notice that we now have more control over how that instance variable is used. If I mark it as public, I can do this and I can do this. But if I mark it as private, and I only want them to read the value but not write the value, then I'll just make a getter and I won't make the setter. I won't write the setter. I just leave it off. Right? So then you can access it with the getter, but you won't be able to set it using the setter, which is actually what we want in this case. So we don't want that setter, but we do want the getter. And then over here, what does that mean? That means that if I want to access the ID, I need to use the method that I wrote. Instead of accessing it directly, you have to go through the accessor method. You have to go through the getter. So I would say get ID. And notice the parentheses after to really indicate that, hey, we're calling a method now. We're using a method here. So notice that after I change this to use the getter, this line is happy. There's no more errors here, but this line is still upset. I can't do it. Perfect. It's exactly what I wanted, right? I can now look at the ID all I want, but it can't be changed. Nobody's allowed to mess with it. Perfect. So to kind of wrap that example up, the sort of Cliff's Notes version, I guess, of that little example is to remember that when we mark things as private, we mark all of our instance variables as private, and then we write getters and setters when we need them. I think that's another important thing to point out. Sometimes students who are new at this will get in the habit of just always putting in the getters and setters for every instance variable that they make. And I understand, being proactive about it, but we do this for security reasons, right? So the proper way to think about it is I'm going to mark everything as private, and I'm just going to keep going and try and do what I'm supposed to do. Once I've determined that I need a getter, then I will write the getter. Once I've determined that I need a setter, then I'll write the setter. But I'm not just going to put it in there preemptively. I'm going to wait until there's an absolute demonstrated need for it to exist before putting it in there. Another thing that I think it's interesting to point out, this is such a common thing to do, such a common thing for us to do that I don't often write these myself anymore. I would encourage you to write at least a few of them just to get used to the idea and get a little practice under your belts. But once you are comfortable with the idea of getters and setters, I very much would encourage you to use your IDE to do it for you, or whatever code writing method to do it for you that you prefer. In Visual Studio Code, we can do that by right-clicking and then going to Source Action. And you can see that the options we care about are right here. So if I select Generate Getters and Setters, it's going to ask me to select which of the 3 instance variables I want to generate getters and setters for. So I'll select the first 2 since we already did the ID, and then hit OK, and then poof, there they are. There's my getter and setter for the name, my getter and setter for the email. So these are such a common part of programming, object-oriented programming in particular, that many tools will have little shortcuts for you to create these, save you a little time and effort. It is still your job as a programmer to decide when you need them. and when to include them and how to use them appropriately, right? So it won't do that for you, but it will write the code for you. Any questions on this one before we move on to our next example? Okay. So I already touched on it a little bit, but I did want to talk for a moment just about the difference between static and not static things, and especially what that means in the context of this class for the remaining, 5 weeks that we have left. Um, Up until today, all of the methods that you wrote were static, every single one. After today, none of the methods that you write in this class should be static, except for the main method. That is the one that will always be static that we're going to continue to use. Every other method that you write, though, is going to be non-static. What does that actually mean? That means that we're using objects. We're using objects. So instead of just calling the method directly, we have to call the constructor first and then call the method upon that instance. I also want to point out, even though I'm not going to show a lot of examples about it, I also would say that I probably would not ask this on the exam either. That word static can show up with variables. So here's an example of not a method that is static, but a variable that is static. This can be useful. So what this is used for is when we want to have one value that is shared across all instances of a class. So if I create 10 different instances of person, they will all share this value. So if one person changes this value, then all 9 other person objects would see that new and updated value. So this can be a common technique to share a single piece of information across many different instances of a class, which does come in handy from time to time. It is not the most common thing. The bigger takeaway that I want you to get from static versus non-static is the idea that static things do not require objects, do not require instances, but non-static things do require instances of objects. And that is what we care about in this class for the remaining 5 weeks. We are very much in the object-oriented world. Static things are no longer welcome here. We care very much about writing non-static things and using good object-oriented programming. So I know there's a lot of other examples in this section. I'm not going to go over those though. I just wanted to kind of point out the high level stuff, the important takeaways from static versus non-static. If anybody does have any questions though, I'd be happy to pause here. Yeah, in the back.
Why you created a private variable that had both a getter and a set, as opposed to just sending it to public?
Yes, there are still reasons why you might want to uh, create a private variable with a getter and a setter instead of public. For one thing, the idea of having public instance variables is like, even if it is not required from a security standpoint, is still so frowned upon that you'll get some weird looks if you do it, uh, even if it's not going to cause any problems or errors in your code. But to more completely answer your question, sometimes there are instance variables which do not follow the simple path in terms of getting and setting. Maybe, like if I'm setting someone's age, for example, I need to check and make sure that it's positive, right? And you didn't give me a negative number because that doesn't make any sense. So in that particular case, having it be public is bad because if it's public, it's going to take any integer you throw at it, including negative ones. So marking it as private and then writing the getter and setter yourself allows you to do that extra check. So I would say though that even if that's not the case and you're still just writing the simplest getters and setters, still the proper thing to do is mark it private and use the getters and setters. If for no other reason than to be consistent about the way you access your instance variables. Yeah, great question though. Awesome question. Any other questions I can address before we move on to our next example. Okay, awesome. I think this is going to be our last example of the day, and I'm going to need your help. So what I want to do is create an object. I want to design an object. So start from scratch, from nothing. So we start out with absolutely nothing. And then I'm going to say, I want to make an object that represents this. How do I do that? What are the steps that I need to take? Because that's what I want you to get used to as programmers. We want to be able to look at basically any object and think, how would I create a representation of that object on the computer? And it really will change the way you look at the world when you get used to it. You'll start looking around and thinking of normal everyday objects in computer terms, right? Like person dot get name and all that stuff. But how do we do that? And this is also what you're going to get practice doing in the studio on Wednesday. You're going to be presented with various types of objects and be asked to write code to represent those objects. So I am going to start out with a simple one and make an object to represent a cat. Make a class to represent a cat. So I want to write some kind of program to simulate cats. Maybe I'm a cat researcher. I don't know if that's a thing, but if it is, it sounds really cool. Um, so where do I begin? How do I start, creating a class to represent a cat? I usually start with the instance variables. And remember that the instance variables, there's a relationship. What's that relationship between an object and the instance variables? Has a, right? Has a. So this is where I need your help. Can y'all help me? What are some has-as for a cat? Cat has a name. Love it. Keep going. What else we got? Color. Okay. Any other ones? Gender. Sure. Age. Yep. Breed. Love it. Any other ones y'all can? I'm sorry. Size. Okay. This is a great list. And we can keep going, right? Like I think that's one of the points that I like to make here is that the list of things that cats have is long. In fact, I could think of some other ones. In fact, some that maybe I'll insist upon, like fur, for example. Or last semester when I did this, somebody said cat has lives, right? Because they all start with 9 or whatever. So okay, yeah. Cat has a voice, right? Makes sounds. Most of them do. So the list could go on and on and on and on. We don't necessarily need to do all of these, and we probably won't do all of them for the sake of time. But depending on the code you're trying to write, simulation, right? How much detail you want your cats to have is going to dictate. Do I need to do all of these on this list, or does their gender not matter to me for the simulation that I'm doing, the experiment that I'm doing, right? So I can leave that one off. Maybe it's not relevant. But once we have our list, I'm going to go ahead and pick uh, the ones that we're going to use. So name, age. I want to do fur as well and voice actually. So once we have those, once we've picked the ones that we're actually going to use, we need to code them up. So the way we do that, always start with the word private. That's the easy part. That's the easy part of the formula. Followed by the type. So for the name, it's probably going to be a string. That one's done. Then for age, it's probably going to be, probably going to be an int, right? I suppose if you wanted to celebrate half birthdays, you could argue for a double there. That's your choice. If you disagree with my data type and you want your simulation to work differently than mine does, then by all means, go right ahead. That is your choice. For the amount of fur, I'm thinking of this as the amount of fur, right? So quite literally, how many hairs does the cat have? Probably an int. right? And then for the voice, so what does the cat say? What does the cat sound like? That's also, I think, probably going to be a string. Here's one that I'm not going to do today, but I want to think about, I want you to think about it just as kind of a little thought exercise. What if so one thing that a cat has a mother, right? Cat has a mother. Could I make an instance variable to represent the cat's mother? The cat's parents? Absolutely, we could. What would the type be? It would be a cat, right? The type of the cat's mom is also a cat. Think about what that means, right? Wait a second. I'm not even done making the cat class and I'm already using it as a type? Sure. Sure. Anywhere that we have used a type, we can now use our classes as types, and that is why we do it. That is like the whole point of doing it this way because it gives us this flexibility. If we didn't have the cat class, how could we represent the mother? It'd be very hard, right? We'd have to basically duplicate all of these and say string mother's name, string mother's age, string mother's fur, and that would be very clunky and complicated, right? But we don't have to. We can just use a cat object. I think that's a great thing to point out. I am going to not quite go into that from a coding perspective today, but on the homework assignments this week, you'll see that come into play again, actually. Cool. And so once we have our list of instance variables, our next stop is to, well, let me ask you all actually a question before I say where our next stop is. There's two categories of things in a class. We just did the first one, which is instance variables. What's the second category of things? You're close. Constructors are methods. Yes, methods. So constructors do fall in that category, but there are other types of methods as well. So the two different categories of things in a class are instance variables and methods, of which I always start with the constructor. Constructor is always going to be the first method that I write. It's so important. So, all right, in order to write the constructor, it has a similar formula. The word public followed by the name of the class again. That's how a constructor has to be written. And now we have to decide what we want the parameters to be. This is actually an important choice, right? Because remember, if we give them parameters, that means that they have flexibility in terms of the types of cats that they create, which might be important. On the other hand, if we have 20 instance variables, that could get kind of unwieldy as well. And so some of them might need to be set in other ways. In fact, I'm going to make an argument, which you don't necessarily have to agree with, that only 3 of these 4 need to be brought in as parameters. So I'm going to pick name, fur, and voice as, oops, except I made a very basic mistake here and forgot the types. My fault, my fault. So I'm going to take those 3 in as parameters, and I'll set those in the usual way. Although, wait a second, I kind of have a problem here. It's not underlined in red, but it is underlined in yellow, and it's still actually a big enough problem that we need to look at it and try to figure out what's going on and talk about it. It's saying that the assignment to variable name has no effect, which seems odd. I'm trying to take this parameter and store it in this instance variable. Why is it having a problem?
Same name, there's no way to tell them what.
Yeah, there's more than one variable with the same name. This parameter has the same name as this instance variable. So it actually is doing something a little bit simpler than what you suggested. It's making an assumption. If it sees a variable name and there's more than one to choose from, it's just going to pick the closest one. And in that case, it's this. This is the closest one. So it's quite literally using the same variable on the left-hand side as the right-hand side. It thinks we're taking this parameter and setting it equal to this parameter, which does seem silly, right? There's no sense in doing that. That's not a very useful operation. There's two ways you can fix this. Actually, all of the examples that we looked at before now avoided this problem by just not having two variables with the same name, right? I think they use the word init for initial, and then uh, now there's no ambiguity. We know that the parameter is called init name, and the instance variable is just called name. But you don't have to do it that way. In fact, I personally would probably prefer to leave it like this and solve this problem the second way, which is to use the this keyword. It's a very, very important keyword when using object-oriented programming. We've actually seen it a little bit before, but just to really nail down that definition, right? This represents the instance which we are currently working on. So since we're in the constructor, this is the instance that we are currently constructing, the one that's currently being made. If I'm in another method, right, this represents the instance that is on the left-hand side of the dot when the method gets called. We saw that when we looked at the P1 and P2 objects before, right? So another reason why we use this is to prevent ambiguity, like in this particular situation. Now, this is very clearly referring to the instance variable, and this one refers to the parameter. In terms of your own coding, you can do it either way. I'm not going to mark you wrong for doing it the other way on the exam. If you want to keep the variable names different, if that's easier and less confusing for you, awesome. If you want to use this to disambiguate, also awesome. Doesn't really matter to me which path you take, but I think it's good to know that both paths are available. You'll see people do it both ways, so you still need to know how to read that code. But I'll go ahead and set the other instance variables in the same way. And that leaves us with the fourth instance variable that we didn't take in as a parameter. And here's a situation where you might disagree with me, but this is my program. The way that I want to write this program, I'm going to make the claim that if I'm making a new cat for the very first time, all brand new cats have the same age. All cats, when they're first created, start with an age of 0, right? They're brand new. There are some limitations to this. If I want to make an instance of a cat to represent an older cat, right? Then I have to figure out how to age it, right? I have to figure out how to make that age number go up. So maybe this isn't the best way for your cat simulation. Maybe you would prefer to have that come in as a parameter to the constructor as well. Okay, you get to make that choice, right? I'm not trying to say that one way is better than the other. I'm just trying to point out that there are different ways to do it. They both have pros and cons. They both have their uses. They both have their situations in which they're useful. But you'll see it done both ways. So I think it is important for you to know that both of those options are available. And when to use one versus the other. But feel free to make yours different if you don't like what I did here. Notice, though, that we are done. I wrote the constructor. It has succeeded in its goal, which is to make sure that all 4 instance variables are set. So we've done that. 3 of them came in as a parameter, and the 4th one is just going to be 0. So we've succeeded in that goal. Now we move on to the next phase of design. So what can cats do? This is where I need your help again. These are going to become our methods. So what kinds of behaviors can cats do? Help me out here. They sleep. They do that a lot. Yeah. Play. Eat is another kind of easy one. They do other stuff too. Yeah. They meow. They say stuff. They talk. Any others? I don't know about y'all, but my couch is just like covered. Just covered. So they shed, right? They shed a lot, right? Oh yeah. One of my cats will do that when she's in a grumpy mood for sure. The other one will just run away. One of them will turn around and come at you if you're not paying attention. But just like we did before, just like we kind of talked about before, right? Which of these do we actually need to turn into methods? Well, it kind of depends on what you want to do. If your goal is to study how cats sleep, then obviously that seems like an important one to include. But, maybe shedding isn't important if that's the case. Maybe how much they shed is not relevant to you. So you don't need to implement that method. But there's flexibility here. We get to decide what the behaviors are and how they act. And the way that we do that is by writing methods for these behaviors. And this is really not that much different than just the techniques we've been trying to teach you to write methods over the last few weeks. So if I wanted to make one for talking, right? Public void talk. I'm just going to keep this one pretty simple. So cats have a voice because cats sound different, right? They don't all sound the same. So I think really then what we need to do to make a cat talk is to just say, print out whatever your voice sounds like. It's very simple. It's almost trivially simple. If you think it should be more complicated, you can make it more complicated. You can design your cat however you want, but this is the choice that I'm going to make. Let's talk about maybe shedding, right? So public uh, void shed. Oops. This one I think is a little bit more complicated. Not all cats shed. There are some cats that actually don't have any fur. You can Google it if you don't believe me, but just brace yourself because they look real weird. They're kind of silly looking. Most cats though do have fur, right? And do shed. And so, you need to have fur in order to do that. So I think the necessary thing to do first is to say like if this dot fur is greater than 0, right? Make sure you actually have hair left on your body with which to deposit on my couch. And then, uh, if it is greater than 0, then we'll just deposit some of it on my couch by saying, I don't know, minus equals 20 hairs. Another simplification, I doubt my cat is shedding exactly 20 hairs on my couch every time it sheds. It probably varies, right? You could bake that in if you wanted to. You could make it be random. You know how to do that. You could bring it in as a parameter if you wanted to control. Maybe you care about this and you want your simulation to have control over this fact. Those are all choices that you can make, and they're all acceptable here, right? I'm not trying to say one way is better or worse than the other, just trying to show you how you can design your objects and use your objects. But ultimately, when we are finished with our creating our objects, creating the instance variables, and then creating the constructor and the methods, we then need to, whoops, forgot the return type there. We need to, much like we saw with methods, this is just a template. So this code by itself does not do anything. We need to first create instances and then call methods upon those instances. And so, that's where we would do things like call the constructor. So I might call a constructor to represent my cat Franklin. Um, his name is Franklin. He is moderately furry. I don't know, 5,000. And Franklin is a meow wow wow kind of a cat. You know what I mean? And then my other cat, Lindsay, her name is obviously Lindsay. She has shorter hair than Franklin does. So in terms of quantity, I don't know if that actually means she has like fewer hair follicles, but I'm just for the sake of our simulation going to say that she does. And Lindsay is a much more shy cat. She likes being pet for about 5 minutes a day. And she's much more of a mew kind of a cat. You're more likely to see her hiding under the couch than in my lap, right? She's always around, but she's never like in the spotlight. Whereas Franklin is up in your business all the time, whether you want him to be or not, right? And so now we can, simulate my two cats. Or if you have cats at home, I hope you didn't make my cats. I hope you made your cats, right? Simulate your cats. One thing that I like to do is to think about what my cats would do, and they do get along with each other. Sometimes I hear them talking to each other. So, hey, maybe I could. What are they talking about? I think they're probably talking about shedding all over my couch. Personally, it's kind of what I think they're talking about. But we could write a little story, right? Let's make my two cats meow back and forth to each other and shed a whole bunch everywhere. Well, okay. While while true, or maybe while Franklin has hair? How do we say that? Has fur left. While Franklin still has fur. How do we do that? Hmm. In order for me to do that, I have to know how much fur Franklin has, which is in this instance variable. And so if I want to access that instance variable, I probably need to make, did you have a question? Yeah, do you remember what that's called? A getter. Yeah, exactly. I think we need a getter here to pull this off. So, all right, public int get fur, and then we'll just return the amount of fur that they have. All right, cool. So now I can say something like while Franklin dot get fur is greater than 0. So while Franklin still has fur left to give me, we'll make Franklin meow, Franklin talk. We'll make Lindsay talk, and then we'll make Franklin shed a bunch. We could make Lindsay shed too, I suppose, if we wanted to, but Franklin is more the problem, if I'm being honest. You can tell him I said that. But like, this is a story. We created our objects and we use these objects. It's a silly story, right? But it's a story nonetheless. While Franklin still has fur left to shed, make Franklin and Lindsay talk to each other and make Franklin shed some more. This is a regular, Saturday afternoon at my house. And if we run this, you'll see that, okay, here we go. They meow to each other a bunch, and there's no indication really, of how much they shed until you see that it actually does stop, meaning that Franklin's run out of hair. But if we want to make this simulation more realistic, obviously Franklin is growing more hair back, and that's not represented anywhere. So there probably should be a method to make him grow more hair, maybe depending on what he eats. And if I really wanted to have an indication of this, maybe I should have a couch object that, collects fur, and then I can ask the couch, hey, how much fur do you have on you? And then a vacuum cleaner object to come by and clean the couch, right? So you kind of see the point I'm getting to with this. Once you get used to the object-oriented way of doing things, literally any object that you can conceive of can be conformed into this kind of program. So then we can, what do I want the computer to figure out? The sky is the limit, right? If I'm concerned about modeling a particular object, I can follow these design principles to make that object and run that simulation on the computer. That's programming. It's a big chunk of the programs that people write right there. But I have covered a ton of ground today. I've thrown a lot of new concepts at you. So, with the few minutes that we have left, let's first take a moment and be very appreciative that we don't have a quiz today, right? But also, does anybody have any questions? Does anybody want me to go over anything again before we wrap things up for the day? Yes, over here. So in the earlier examples, so you're talking about these. I mean, it's just to avoid the name conflict example that I was showing before. So if I call them the same thing, then we run into this ambiguous situation. This is bad. So one way to avoid that is to make sure that I don't have two variables with the same name, and they just distinguish that by using init, meaning initial. So the initial name is this. It might change later, but I'm in the constructor, so initially it is this. Was there another question? Yeah. Encapsulate, sure. So, the idea behind encapsulation is that before today, if I wanted to create a program, if I wanted to have data on my program, especially, I would create variables. So I can make strings, I can make ints, I can make doubles, all those different types of things, right? But the idea behind encapsulation is that there are some things in life that are too complex to be represented by a single int or a single double. But if I had multiple of them all packaged together in a single unit, I could then maybe represent some more complex things. So in the case of cat, right? Our cat object, I can't represent a cat as an int. Doesn't make sense. I can't represent a cat as a string. You know, cats are more complex than that. So how did we represent cats? We represented cats as, in this case, four instance variables that are all encapsulated within the cat class. Does that kind of help clarify? Yeah. We're not limited to four, right? You can have as many as you need, as many as you determine are necessary. Although, that being said, if you have 100, that's maybe on the other extreme. You can't have too many. It's hard, but it is possible. Yeah. Any other questions? Great questions today. Great feedback today. Thanks for helping me with the cat example, putting up with my bad jokes. I'll see you all in the labs on Wednesday. Have a good rest of your day, okay?